Welcome. In this lesson, we'll learn how to architect multi-agent systems where specialized LLM agents collaborate. We'll cover defining roles, the handoff and delegation patterns, how agents communicate through shared state and messages, and how to keep these systems controllable in production using LangGraph. A single agent juggling many tools in a huge prompt tends to forget instructions and pick the wrong tool. Splitting the work into specialists keeps each prompt short, focused, and testable, and lets you grant least privilege tool access per role. The trade-off is added latency, cost, and new failure modes, so reach for multi-agent only when a single agent genuinely can't handle the task well. Treat each agent like a focused team member. Give it a single-sentence mandate, the minimum set of tools, and a clear input-output contract. Crucially, define its boundaries, when it should hand off rather than improvise. A reliable signal that a role is too broad is when its prompt keeps saying "and also handle this." That's your cue to split it into another agent. There are three common shapes. The supervisor topology uses a central router that decides which worker acts next. It's the easiest to debug and a great default. The network topology lets any agent call any other, flexible but prone to loops. Hierarchical stacks supervisors over teams of agents for very complex workflows. Always start with a supervisor and only graduate to hierarchical when that supervisor prompt gets overloaded. In LangGraph, an agent performs a handoff by returning a command object. The goto field names the next node to run, and update writes new data into shared state. Here the researcher finishes its work and hands control back to the supervisor along with its findings. Note the distinction: delegation means you expect a result returned for a subtask, while a full handoff can transfer ownership of the conversation entirely. Agents share information two ways. Shared state is a typed object every agent can read and write, ideal for accumulated artifacts. Message passing appends to a running list of messages. The biggest pitfall is context bloat. Forwarding every internal message between agents wastes tokens and confuses models. Instead, pass summaries or structured payloads, and use separate state channels like research_notes and draft rather than one giant transcript. Because agents hand control back and forth, infinite loops are a real risk. Always set a recursion limit when invoking the graph, give your supervisor an explicit termination path to end, and make workers report failures back gracefully rather than crashing the whole graph. Finally, trace and evaluate each agent on its own. Tools like LangSmith let you see exactly where a handoff went wrong. To wrap up, here's your build checklist. Write every agent's mandate in one sentence. Define the shared state schema and which keys each agent owns. Choose a topology, defaulting to supervisor. Implement handoffs using command with goto and update. And always add recursion limits and clear termination conditions. Follow these and your multi-agent system will be both capable and controllable in production.